The sun produces a colossal amount of energy. Under the intense heat and pressure at its center, nuclear fusion takes place. Hydrogen ions collide and fuse together, causing energy to be released. If humans could recreate the sun's power here on Earth, the potential for a limitless source of clean energy for future generations would be in our hands. But this is not the stuff of science fiction. Behind me is JET, the largest and most powerful fusion experiment in the world.
JET is in effect a man-made star. In this donut-shaped device, we heat hydrogen to temperatures in excess of 300 million degrees centigrade. That's 10 times hotter than the center of the sun. At these temperatures, hydrogen starts to fuse and produce helium. Helium is slightly lighter than the hydrogen ingredients that makes it. So this small difference in mass releases a huge amount of energy. This soup of atoms that we call the plasma, it's very hot and it's all kept together by very powerful magnetic fields.
It's easy to see why there are such high expectations of nuclear fusion. World demand for energy is soaring, but oil reserves are declining. We're not yet sure if renewable energy alone can support us, and traditional nuclear power is fraught with problems. So, is nuclear fusion the answer? So what's the difference between traditional nuclear power and nuclear fusion?
Well, in traditional nuclear power, nuclear fission, you're actually splitting atoms apart to create the energy, whereas in fusion, you're pushing them together and combining them, and that's the way that you release the energy.
And what's different about nuclear fusion compared to sort of traditional fossil fuels in terms of energy production?
Well, 1 kilogram of fusion fuel can create more energy than about 10 million kilograms of fossil fuels. So there's a huge energy potential there. And there's also very little radioactivity and no greenhouse gases, which means that fusion has the potential to satisfy all the world's energy needs without the risks of global warming or the politics of conventional nuclear power.
So why aren't we using it already?
Well, at the moment everything's still very experimental. The challenges behind fusion are great. For example, all the particles you have to push together, they're all positively charged, so they repel each other. So they don't want to be pushed together. You have to put in a lot of energy just to overcome this repulsion. And that's why the plasma has to be so hot. And then you have to confine it, you have to keep it trapped for long enough for the fusion to occur. And so this takes, this is very troublesome, it's quite challenging. On top of that, you also have engineering challenges. For example, how are you going to deal with the huge amounts of energy that are produced?
There are certainly doubts as to when, if ever, nuclear fusion will become a practical solution to our energy crisis. If it is successful, it may be over 40 years before it will be commercially available, and clean energy is needed now if we are to avoid runaway global warming. It has been argued that the money would be better spent on improving renewable energy technologies that are proven and can be used now. That hasn't stopped a lot of hope and 10 billion euros being invested into the international ITER experiment. That is designed to pave the way for the first prototype commercial nuclear fusion power station.
The ITER project, International Thermonuclear Experimental Reactor, is the final scientific and technological step for the demonstration of fusion as an energy source. It will potentially solve the world's energy problems.
So is fusion the future, or will the holy grail of clean energy continue to remain out of reach? According to the scientists here, the next 40 years will decide.